Conditional probabilities can be represented using what we usually call a tree diagram. We often draw tree diagrams sideways. It would probably be better to call this a path diagram. So imagine a group of people entering on the left. As they come to each branch, some will go in one direction and others in another. For example, suppose a group of people enter on the left, and every time they come to a branch, equal numbers follow each path. We can apply a frequentist approach to the probability a person ends at one of the 5 locales. Since the branches will divide the group in half, 2 branches, or into 3, 1 branch, let's begin with 12 people. So 12 people get to that first branch, and since we're assuming equal numbers follow each path, 6 will take the top branch and 6 will take the lower branch. Along the top branch, 6 people get to the next branch. Again, we're assuming equal numbers follow each path, so 3 follow the top branch ending at the lady, and 3 follows the lower branch ending at the tiger. Along the lower branch, 6 people get to the next branch. And again, here, since there are 3 possible branches, then 2 go along each branch to end at the 3 locations. Since we had 12 people enter, we can use the frequentist interpretation to find some probabilities. The probability a person ended at the tiger is 3/12. But we can also find conditional probabilities. For example, of the 6 people who took the top branch, 3 ended at the tiger. So the probability a person ended at the tiger, given that they took the top branch, is 3/6. Or let's consider one where we're given probabilities. Suppose the probability that a person orders a burger is 1/3, and of those who order a burger, 90% get fries and the rest get salad. Of those who don't order a burger, 25% get fries and the rest get salads. Now, our events seem to be B, a person orders a burger, F, a person orders fries, L, a person orders salad, where we'll avoid using S since we usually use that to represent our sample space. To decide how our tree diagram should be set up, let's think about this as a sequence of decisions to be made. If our first decision is whether a person orders a burger, we have this unconditional probability of 1/3. But if our first decision is whether a person orders a salad, we only have conditional probabilities. Likewise, for whether a person orders French fries. So we can't make these the first branch since we don't know how many people will take them. So our first branch should either lead to a burger or not. Now, of those who order a burger, some get fries and the rest get salad, so our second branch will take a person either to F or to L. Of those who don't order a burger, some get fries and the rest get salad, so the second branch will also lead to F or L. Now, while we could show these branches rejoining, it's easier to draw and read the tree diagram if we don't allow paths to rejoin. So we'll introduce additional copies of F and L as destinations for the people who travel along each branch. So for convenience, let's label how many take each branch. 1/3 take the branch leading to B, which means that 2/3 take the branch leading to B complement. Of those who go to B and order a burger, 90%, 90/100ths, take the branch leading to F and order fries, and the rest take the branch leading to L. Of those who don't order a burger, 25% take the branch leading to F, and the rest take the branch leading to L. Now, since our denominators are 3 and 100, let's suppose we have a sample of 300 people. Of these, 1/3, 100, order a burger, and so they're at B, and the rest are at B complement. Of those at B, 90% of 100, or 90, order fries and end at F, so 90 end at this F, and the rest end at L. Of those who are at B complement, 25% of 200 order F, so 50 end at F, and the rest end at L. And now we can find some probabilities. Of the 300 customers, we see that 140 order fries, so the probability someone orders fries is 140 out of 300. And 160 order salad, so the probability they order salad is. What about the conditional probability that someone orders a burger given that they've ordered fries? We could find this probability by noting that of the 140 who ordered fries, 90 of them came from the group that ordered burgers. And so this conditional probability is